Okay, now next I'd like to show you how to use the integration by parts formula to integrate the so-called transcendental functions. Examples of transcendental functions are, as listed here, tangent inverse, sine inverse, cosine inverse, natural log of x. Very loosely, you can think of these as functions which don't have nice algebraic formulas for them. They're defined in other means, and we know they're derivatives, and that's the key for us. The derivatives have nice algebraic formulas, the functions themselves do not. And we're going to use the fact that we know they're derivatives, along with this integration by parts formula, to figure out how to integrate these. Now actually, as it turns out, it's going to be fairly straightforward. We're going to use the same procedure for any transcendental function. So here's the trick. We're always going to let u be the transcendental function. For example, u equals tangent inverse of x, and we're going to use this to integrate tangent inverse of x. So if I let u equal tangent inverse of x, then my dv is always going to be equal to dx. So let's see how this plays out now. I'm going to start it over here. Set up my little grid just like we always do. Now, by letting u equal tangent inverse of x, I can proceed as long as I know the derivative of u, and that's the beauty of these functions. We know they're derivatives. So the derivative of tangent inverse of x is 1 over 1 plus x squared. Antiderivative of dx, that's going to be x. So I get this set up. Now, u times v is x, tangent inverse of x, minus the integral of v du. That's going to be x over 1 plus x squared dx. Now, assuming we can integrate this, we're going to be good to go. And this is one that we learned how to do with substitution. If we let u equal the denominator of this fraction, 1 plus x squared, the derivative of that is 2x. And that's going to allow us to cancel this x out and get a du over u integral. Now, we're going to go ahead and spell all this out for you. So just to do this little side problem, let u equal 1 plus x squared. We're going to use u substitution here. The derivative of that, du over dx, is 2x. And if we solve this for dx, we get 1 over 2x du. And let's substitute everything in for this integral here. So, the integral of x over 1 plus x squared dx is going to be equal to x over u times 1 over 2x du. And since everything but the u's cancel out, this was an appropriate substitution. This will simplify down to 1/2 integral du over u. And this is one of the basic formulas that we had you memorize. 1/2 natural log absolute value of u. So that's 1/2 natural log absolute value of 1 plus x squared. Now it's worth noting that 1 plus x squared is always positive because x squared is always positive, so the absolute values are actually redundant here. So I'm going to change those to parentheses. You can leave them if you want, but it is redundant. And now I just glue this back into what I had earlier. So my final answer here, integral tangent inverse of x dx, is x tangent inverse of x minus this. And now let's put on our plus c, and we're done.